So we're going to do page 6 in your notes. We are on our second day, loosely, of 9-1. And what we're looking at is composition, and it's a combination of two or more things. Okay, and this idea of combinations today is going to be about translations. It's transformations. Okay, remember transformations, the big umbrella of this, but we're talking about translation specifically. So we went over from the top left corner here, 6 over, 3 down to find AHM. And we're going to find out what AHM is as we read. So find the single translation that will go from the starting point to the final destination. And by the way, the reason I put you there is so everybody has the same spot on this grid. Okay, it's not like, well, you must find it. You'll figure it out if you're not on the grid. When you do this, you got to make an adjustment because your directions fell off the grid. The grid's just here to help us. You are visiting Washington, D.C. from the American History Museum. You walk 5 blocks east and 1 block south. So from the AHM, I'm going to go 5 blocks east. 1, 2, 3, 4, 5, and 1 block south. This is now the Air and Space Museum, ASM. It's the technical term. I'm sure they stole that stuff from me. Okay, I doubt it, but ASM. Now, let's assume we looked around and stuff, and all right, we're cool, but before we go, we're going to ask a geeky question. You ready? What was the rule to go from the AHM to ASM? Remember, we went 5 to the right, so it's like adding, and we went 1 down because it's like subtracting. So our rule initially was y becomes x plus 5, y minus 1. Does that make sense? Yes, no, maybe, maybe. Now, keep in mind, this is a composition. That was one translation. Well, our second one, I'll do in blue, we're supposed to go. Then you walk 8 blocks west to the Washington Monument. 8 blocks west. 1, 2, 3, 4, 5, 6, 7, 8. So I am now at the Washington Monument. Wow, they fixed it. It's repaired. You guys know that it got injured. It got injured. It was in disarray because there was a earthquake in Washington, D.C. and it cracked during that earthquake. I forgot how many years ago that was. You know, when you get as old as I am, it's like 2 years is like last week. Bless you. Okay, so now here's the thing. We have the Washington Monument. What if we left somebody behind? You know, our family's pretty big or our group's pretty big, and I don't know, who should I pick on to be left behind? What do you think? Are you left behind, Sean? Okay, Sean's left behind because he really likes the American History Museum. He wanted to hang out there for a little longer because he was really into, you know, the little miniature guy exhibit, whatever. But he's going to join us. So what direction does he take from the American History Museum? Okay, so we can all meet there. Yeah, Miss Bloom. 1 block south, 3 blocks west. Okay, but if we're going to do it X, Y wise, how would I do that? Is Y a 3? Think X is horizontal. Y, see, that's why I know. I was just wondering because you were right when you said the west and the south. You were. Okay, I just wanted to make sure we translate that to X and Y. And X, remember, is east-west in this case, and Y is north-south. So if we are going just to transfer that, there, well, first of all, we did 8 and 10, but if we are going to transfer what she said, it becomes X minus 3, 1 minus Y minus 1. 1 minus 1. No. Are you okay with that? Now, the reason why I'm so particular about that is this. As we move this up so everybody can see in the back in the cheap seats, is there a way to have taken these first 2 rules to combine them to become that last rule? And I suppose this should be my last rule, like that. Is there a way I could have done that? I mean, what could I do? I mean, I need some brainiac moves. Yeah, what do you got, kiddo? Add the x's and add the y's without really adding the value x's. It's just the change. Do you see the changes that I'm adding? And we're talking about these. If I added this change and this change, I know I put 0 in there. You guys don't have to put 0. I did this so I'd have something to circle. Okay, we're going to add the y's and we're going to add the x's. So really what it comes down to, this is our composition. Okay, now Sean's pretty happy because he was able to join us and he had direction. But we really are, from where we started in the American History Museum, exactly what 1 block south, 3 blocks west. But we showed it as XY coordinates just for fun, something different, because we're looking at the idea of this translation rule and doing combinations with them. Now I can combine 3, 4, 5, 6, 12, 472. Can you imagine adding 472 combinations of X's and Y's? How many times would we make a mistake? Okay, I wouldn't do that many. But if I wanted to, we could. Okay, and it would still work and we actually get it down. That's translations over a XY coordinate grid. And it's just sliding the piece wherever it's going, up, down, left, right. Okay, does that make sense? Now it's your turn. You guys are going to do exactly the same thing, except we're going to do it with problem 8. And in order for us to be successful with 8, let's start together with our refreshment stand right here in that black dot. 1, 2, 3, 4, 5 over 1 up. And the only reason I'm doing that is making everybody start in the same spot so you guys don't learn that where you start could fall off the world that we're working on. Okay, if it's off our grid, we're off our world. Okay, so don't pull a Christopher Columbus or what they thought that you'd do. Okay, just go ahead from the refreshment stand, RS, and go ahead and read the story and apply it. Go. It's your turn. Okay, so hopefully you read, you buy drinks at the refreshment stand and then you walk 8 rows north. So you're going to watch 8 rows north, 1, 2, 3, 4, 5, 6, 7, 8, 2 rows west or east, and you're at the science fiction booth. Well, then if I do that as a rule, that's x plus 2, y plus 8. Okay, I know the order is weird, but remember horizontal is the x, y, x, and vertical is the y. Okay, now I go from the science fiction book booth, and I use green, so I'm going to use red. I go from the science fiction book booth, and I go 1 row south and 2 rows west, right, to here, to the children's book booth. Okay, so I do that. And remember these compositions, I continue on from where I left off. I don't go back to the beginning, okay, when I do these rules. And now I want to come up with, I get this phone call and I don't know, Katie, she's talking to me, boom, I'm lost. I go, well, remember where we were at the refreshment stand? She goes, yeah, we are directly how many blocks north of it? 7 rows, right? We are 7 rows. So I tell Katie, I know we're 7 rows north of the refreshment stand. And she goes, cool. Okay. And then we hang up and we go back here. And again, I would have just added my change in my X's, my change in my Y's. By the way, you don't have to have like some big city block refreshment stand. This is all about the coordinate grid. Okay. I just thought I'd do something a little different. So it was one of these problems I grabbed. Okay. Questions about how we doing it? Is it okay? Any follow-ups? All right, so now it's quiz time. I know, for lack of better words, you have 3 questions that are just really wondering about, do you gets it? So let's check it out. We are looking at 8, 9, and 10. I did some prep work on these. I would expect to see this type of work. I'm looking for a rule in both 9 and 10. Okay, so go find it and find the other points. But 8, we answered as well. We rehearsed the reversal, right? Remember on Friday, or reversal the rehearsal, or however you want to do it. On Friday, we did this. Problem 8. Rehearse the reverse, remember? That's why I made, yeah, you got to do something like that in 8. All you have to do is just give me the rule. You don't have to do anything else with it. So go. Remember the last time we were in notes, we did rehearse the reversal. Okay, we reversed it, and it's all about going to where you're going to end up and taking the same rules and just reversing it. So if you added to get there, you subtract. If you subtracted to get there, you add. In this particular case, though, I'm going to take both. I got a little cursor here so I can talk about where I'm pointing. I'm going to take both these plus signs and make them minus signs and reverse it. So that's going to bring my P prime, Q prime, R prime, S prime back to PQRS. Okay, so I start where I ended up and go to my beginning, and that's all I do. Okay, and this next one in number 9, triangle XYZ has coordinates x2, 3, y1, 4, and z8, 9. A translation maps x to x prime, which is 4 to 7. Now, x went from 2 to 4 and 3 to 7. Wonder how that happened. What are the coordinates of y prime and z prime for this translation? Well, 2 to 4, I added 2. 3 to 7, I'm adding 4. So my rule becomes that, and I apply that rule in both situations, and I got 3, 8, and 10, 13. Are y'all okay? Okay, head bobbles are good. Even at home, head bobbles is good. It's a real positive mental attitude, helps you understand things. Okay, same idea in 10. Triangle ABC has coordinates A, 2, 3, B, 4, negative 2, and C, 3, 0. After translation, the coordinates of A prime are 6, negative 1. What are the coordinates of B prime and C prime? Well, A's 2, 3, and A prime is 6, negative 1. So I added 4 to my x and I subtracted 4 from my y. So I'm going to do the same thing with those, but I'm going to write my rule first. And the reason why I'm writing my rule is if I get it wrong, a lot of times it's just because I didn't write the rule and I didn't pay attention to what I was doing for each x and y, and I flip-flop them. So as long as I got a rule written, I totally know what I'm going to do, and it's fixable, maybe. Okay, because once you know what you did, you can undo it, and then you can wormy it. What I really meant was, or is, okay. Are there any questions regarding? We're all right? Hey, you ready? Next page is page 7. We are looking at reflections. Reflections. You okay there, Diamond?
Yeah, I'm going.
Okay, I'm just making sure before I slide on. Okay, woo. So you guys are page 9. I've got to get here. Okay, or page 7, not page 9. But now here's the deal. When you get ready in the morning, okay, and you're staring at the mirror, you know, you're out of the shower, you've brushed your teeth, and then you notice something in your teeth or on your nose, in your face, and you get closer to the mirror. And you get a little closer, you can't quite see it, you get really close, and you're like, what is that? What happens when what's your reflection doing when you're getting closer to the mirror? What's your reflection do? It's getting closer. Matter of fact, if I get really super close, sorry, Diamante, I'll stay right here. Well, let's pretend that the mirror touched my nose. What's it appear that my reflection is doing? Isn't it my reflection's nose touching the mirror? So really, I'm like an Eskimo, right? Nose, Eskimos in the mirror. Okay, I know, it's sick and lame, but it's a really great point because I now have my original image, my nose, touching the mirror, and my pre-image, and my image and I are both touching the mirror. Let's look at our diagram here. Right here, A and A prime. They happen to both be touching the line of reflection. They are actually the same point. We can name them differently because we're trying to talk about our original pre-image, and our image, okay? A is our pre-image, A prime is our image, and they're touching the line of reflection, so they are the same point. Just like in the mirror, corresponding points, okay, are the same distance away from the line of reflection. That's how I can, like, if I have something hanging up in the back of my head, I can go push it down and actually get it right away on the first try instead of going, it's here, okay? So just make sure you know that corresponding points are the same distance away from our mirror. That's why as I adjust my position to the mirror, my image of me adjusts its position at the same time. That's why when I play quick draw in the mirror, it's always a tie. Okay, so corresponding points, B and B prime, line up on a segment that is perpendicular to the line of reflection. Okay, perpendicular to line of reflection. So I've got this stuff going on. Okay, those are the things we should be writing down. These are properties we should know now with reflections. Corresponding points are perpendicular to our line of reflection. Okay, points that are on the line of reflection don't go anywhere. They just, that's the reflection. Okay, my nose is on the mirror, my reflection's nose is on the mirror, okay? Now, one of the things you got to pay attention to is what happens when we talk about the orientation of the reflection. Now, when I lift my right arm, what arm appears to move in my reflection? It's the left. If I move my left arm, my reflection's right arm moves. So its orientation has reversed. And how I can recognize this in figures, if I look at how I name my pre-image, ABC, see how I'm naming it ABC and it is a counterclockwise movement, ABC, like that? The orientation switches in reflection, A prime, B prime, C prime. So that's how I know one reflection has taken place. And this is my emphasis of orientation is switched or reversed. One was clockwise, the other one's counterclockwise. And if it was counterclockwise to begin with, then it would be clockwise, my orientation. That would I expect it to be. If I put a clock moving, okay, with a minute hand right next to my mirror, okay, the minute hand would be moving clockwise, the reflection would be moving counterclockwise, okay, as we're going through. Now, what I'd like you to do is use these properties and sketch these two things in one. Okay, corresponding points lie in a line perpendicular to the line of reflection. They are the same distance away. So these should be the same distance away from that line of reflection. So this distance and this distance should be the same. So as I'm doing that, making sure that you understand all that, and I move my little point away, I'm right there. That's my new image, okay, from my pre-image to my image. Corresponding points lie on a line perpendicular, a segment perpendicular to the line of reflection, the same distance away from that line of reflection. Does that make sense? Now, some people were doodling and trying to get this done while we were talking about this earlier. I am not expecting you to be an art student on this. I'm just expecting you to be able to represent and know what's happened. What has occurred? Has it been reflected? Has it been rotated? Has it been translated? Okay, sometimes when there's symmetry in the figure, okay, it's tough to tell. Except when it's a reflection, if something is on the line and we've reflected it, it's still on the line. It could be a rotation, but we're not quite there yet. We haven't talked about rotation. This picture could be surmised as a rotation figure as well. Okay, now, in the second part of one, please go ahead and sketch the other one as well. Okay, sketch them both. It actually is beneficial. I'll give you some time. Now that second part, you should be able to represent that picture, and again, corresponding points are the same distance away on a line perpendicular to the line of reflection. Remember, I know when we sketch like this is an estimate. I get it, okay? But I want you to be able to see visually what's going on with it as we do these. Now, draw the line of reflection. If corresponding points are touching, that drawing line of reflection goes right through, and maybe they can be better than what I did, okay, on mine. Okay, but they should go through and connect those points. And remember, today's objective is to find reflection image of figures if we haven't already picked that up. Now, the thing we're going to do is reflect things in the X and Y axis. So that's the next page, or for me, for you guys, is down a page. And we're looking at this. Draw a line or segment at F because we switch axes at that point. We are switching axes at that point. And what I want you to realize is I'm going to reflect point A, 2, 2, that's over here, okay, that's point A, in the x-axis. So I'm going to get rid of this. We can get rid of that line for a second. I'm going to get rid of that blue line. We're going to reflect it in the x-axis, and the x1 is right here. Okay, that's my x-axis. If I'm going to reflect A, and I'm going to take and reflect A in the x-axis, it's 2 points away, right? I should reflect it 2 points away. So my A actually becomes A prime, which is 2, -2. I'm going to use the prime notation for this problem, by the way, and it's because I do not have coordinating letters all the way across this grid to represent the reflected images. So I'll use prime notation, okay? Now remember, x-axis, this is a XY coordinate grid, and consequently, because of that, all my stuff is perpendicular. These are always perpendicular to each other, vertical and horizontal lines. So B is over here at 4, 4, but now my reflection of B is down here, 4 units, 1, 2, 3, 4, but it's 4, negative 4, my B prime. Okay, 4 units down, 4 units up, that's my B prime. I would like you to do the next 4. Okay, if there is any concerns or confusion about it, I'm walking around and to help you clarify. But turn it off at home. Here, I'll just turn it off and we'll move on. Now, hopefully you're able to take and reflect that point C. So I got point C that's at 2, negative 2. I'm going to reflect over here and it becomes 2, 2. So I'm going to pop over here, it becomes 2, 2. And then I'm going to take point D, which is at negative 2, 2, and reflect it, and it becomes negative 2, negative 2. Okay, and then I'm going to take point E and reflect that, and that's at negative 3, negative 2, and becomes negative 3, 2. And I'm going to take point F, wherever I hid that, negative 1, negative 3, and becomes negative 1, positive 3 right there. Okay, now, hopefully you started noticing that there's a rule, because nothing I can do here can be taught without me showing you a rule that we're using. And we're using this change Y. Now I've got some people that said change Y. I would write the rules down this way, so you have an XY becomes, the preimage becomes X opposite of Y. But now, be very careful about the use of that opposite of Y. Don't say negative Y. And people are like, well, why? It's the same thing, Bloom. It really comes down to the fact that when Y is already negative, you don't think you have to apply the rule, and you actually do. That opposite of Y means you're taking the opposite of whatever the Y value is. So make sure it's clear. And when we do that, notice that in problem C, my Y value was negative 2. I take its opposite, and in C, it's 2, 2. I see prime. So be advised, that's how it's working. The next one is working on reflecting across the Y-axis. Same rule, except it's a vertical axis instead of horizontal, okay, as far as my reflecting rules are concerned. But specifically, we're going to look for a rule that we're going to apply for the y-axis. So I'll do the first one with you. We got A is 2, 2, but now I'm going to flip it this way. And A, which is 2 units away from the y-axis, becomes kind of D. It's negative 2, positive 2. So now I've got to figure, well, what's changing this time when I reflect across the y-axis versus what changed when I reflected across the x-axis. And what you guys are going to do is go ahead and do H, I, J, K, and L. Go. Now, this next reflection of B, which is 4, 4, B is 4, 4, so B is over here at 4, 4, and I'm reflect that. That's going to be negative 4, 4. Okay, so I'm going to pop that in. And C is at 2, negative 2. C is at 2, negative 2. Well, it's going to be negative 2, 2. Boy, I'm starting to understand that one thing is changing, the other one's staying the same. And maybe you're recognizing it too. At D, I got negative 2, 2, and it's going to go across here at 2, 2. Okay, and at E, it's negative 3, 2. E is negative 3, negative 2, excuse me, and it's going to come across here at positive 3, negative 2. And then my last one's going to be positive 1, negative 3. Well, hopefully we recognize I'm just changing my X value. Okay, and my rule becomes negative XY. Are we doing okay? Now, for you guys at home, I know you can't ask questions in class, but make sure if you do have questions, you get to school and you ask them, because those unasked questions are the ones that always affect your grade adversely. Going on, recall from linear algebra, and I should have included y minus y1 equals m times the quantity x minus x1. Should have included that years ago, okay? But those, I'm just kind of touching on them. You got a list of equations that you've used, and if you need to know how to use the y equals mx plus b and the y minus y1 equals m times quantity x minus x1, let's talk. But really what I'm here for today is talking about horizontal, vertical, in slant lines. Okay, y equals x and y equals negative x. So y equal b is a horizontal line, and maybe I should get a little cursor. It's really hard to follow along where we're at. Y equals b is a horizontal line that crosses the y-axis at b. Okay, x equal a is a vertical line that crosses the x-axis at a. Well, we got to be thinking about that. If I'm crossing the y-axis at b, I've got a y horizontal line crossing the y-axis at b. These are all y equal values right now. I'm doing a billion of them right now just between these as we go through. And I want to make sure specifically, this is y equal 1, y equal 2, y equal 3, y equal 4, y equal 5, y equal 6. Making sense? It's a y equal a number. It's a horizontal line that crosses the y-axis. Now, with this in mind, the x-axis has a y equals 0 equation. That freaks people out. Y equals 0 is the equation of the x-axis. It's a horizontal that crosses the y-axis at 0. Y equal negative 1, y equal negative 2, y equal negative 3, y equal negative 4, y equal negative 5, and so on. Let's talk about x. X equal negative 6, negative 5, negative 4, negative 3, negative 2, negative 1. X equals 0 is the y-axis equation. It's a vertical line crossing the x-axis at 0. Okay, y equal 1, vertical line crossing the x-axis at 1. Y equal 2, vertical line crossing the x-axis, at 2. And x equal 3, x equal 4, x equal 5, x equals 6. Okay, now the reason why I'm going so crazy about this is the most popular ones we'll use. Specific examples, y equal 2, it's right there. Write in y equal negative 4. The equation y equal 2 I provided, I want you to write in y equal negative 4. Y equal negative 4 is the next one you're going to do. Y equal negative 4. Hopefully you're down 4 on the y-axis. Remember, y equals, it's going to cross at negative 4. It's going to be horizontal. Just a number will be a horizontal line. For x equal, just a number, it's going to be a vertical line. Okay, so x equal, just a number, a vertical line at x equal 2 is here. Vertical line at x equal negative 4 is here. Okay, we doing okay. I got 2 more lines to review. When you are told that y is equal to x, and you know that the value of y is 4, what's x if y equals it? 4. X has got to be 4 as well. If I know y is 0 and y equals x, what's x? If y is 0, x has got to be 0 as well. Every time I do that, I'm looking at a line that's the diagonal. This is a 45-degree line. People, how do you know that? We just did 45, 45, 90 triangles. So you got to keep in mind that if I go 4 over, 1, 2, 3, 4, and I go 4 up, 1, 2, 3, 4, I'm back on that line. Crazy. This is a 45, 45 line, okay? I know it makes 45 degrees with the axis, but I don't have to know that. I just need to know that this is the y equal x line. And keep in mind, if I say y equal negative x, and by the way, notice how I have y equal x there, and I have x equal negative 4, and y equal 2, or y equal negative 4, and y equal 2, and x equal negative 4, and x equal 2 for these lines I'm representing on this, I would totally write them in for you too. Okay, if I were you. This one, y equal negative x. Somebody should actually put that in there. Y equal negative x is the y equals negative x line. Tomorrow we're going to talk about the slant lines and then talk about a rule for them. Okay. Today I'm just talking about vertical and horizontal. I got one screen left and we're done with notes, but I want to make sure it's clear. This is the hardest part because no longer I'm just talking about the x-axis and the y-axis. I can move these lines. So you have to know which one we're talking about and how to graph it. It won't be just given to you, okay? So you got to make sure you know. So let's talk about A. If I can move this around a little bit, there we go. Get this up. In A, I'm talking about a horizontal line, apparently. Let's pull that out. I'm talking about y equal 1. So I'm going to talk about a horizontal line. Let me get rid of this. Y equal 1. Y equals 1 is right there. Okay, do you see y equal 1? It's a horizontal line crossing at 1. Some people had a hard time because of the lines on this. This is x-axis. Oh, that was a really good use of color. This is the x-axis. This is the y-axis. So keep that in mind. I just look for the x and y to find out which ones are the axes. And then I've got y equals 1 right here. A is 1 above it. My new A is 1 below it. Are you okay with that? And now people are like, well, yeah, but how do you figure out how to talk about it? Well, I go back to the original address, and this is +2, 0. So I got +2, 0. Well, let's pull that 0 back over here because apparently I needed it. Are you okay with that? Questions about my new point A prime? Remember, it still runs on the same rules we've been applying. I first have to draw my horizontal line in this case, because it's y equal 1. And then I find how far A is away from it. And that's how far away from it on the other side of it is my prime, my image. So in this next one, I'm looking at B, which is 4, 4. B's up here, 3 units above the line. It's at 4, 4. Okay, 3 units above the line. 3 units below the line, it's actually at 4, -2. So my B prime is 4, -2. Are you okay with what I have done? I have some people looking at me like I have just pulled something out of the pant leg and go, wow, that was a cool trick. He didn't even bend down. Really long arms. Are we doing okay? Yes, no, maybe. Thumbs up would be good. I'm still looking at people and it's a little scary. Yep, promise? Okay, all right. So now, do C, D, E, and F, please. Pay attention to which line you're writing in there. Go. Okay, so here we go. Let's check them. Are you okay? Good, bad, or ugly? Explanation. Reflection over x equal 2. X equal 2 is this bad boy right here. Since C is on the line, it don't go nowhere. It's 2, -2. Okay? I'm going to pull that away. X equal 1 right here. And D, I got point D is 3 units away. So the new D is 3 units away out here. And it is 4, +2. That's where that comes from. That new D is right there. 4, +2. Okay? Now, my next one. In E, pull this out. I'm going to go E, which is y equal 2. And E goes off the screen because this is 4 units. This is 4 units. It's up here. So when I go out to count this, it's 1, 2, -3, 1, 2, 3, 4, 5, 6, 3, -3, 6. But just because it's off the screen, it doesn't mean I can't find it. Okay, it's right here. Here. We found it. It was in the woods, just like, you know, I'm playing golf, right? Goes off in the woods. I got to find it. Okay, but we should have little chips inside those balls so I can find them. But they'd be really expensive. But I would only have to buy one ball, right? Okay, connected to my cell phone. X equal -1. Okay, so I got to go back to the X's. I got to flip flop. I'm going to clean up my board a little bit. I'm going to go back to the X's. X equal -1, and I'm talking about F. Well, F is right here. It's on the line, so it's still -1, -3. And that's the deal with horizontal, vertical lines, and reflections. Okay, thanks for your time today, you guys. I really appreciate it. I know it got long, but you're rock stars. Okay, see you tomorrow or the next time you're in class.